In this video, we are going to be covering Chapter 3, which is on data visualization. In the last chapter, we looked at data just in general, categorizing our different types of data and learning some terms about data. In this video, as already mentioned, we're going to be visualizing that data. Now, when we go to visualize our data, there is one major thing to keep in mind. The whole point of putting data in some format for us to look at easily is just that. We want to be able to look at this data, right, displayed in one of the ways that we're going to discuss. We want to be able to look at that display and quickly and easily get the information that we're intended to, right? So any kind of visualization is going to have a purpose. It's going to have some information that is meant to be imparted, right? So the quicker, the easier we can get that information as the reader, the better. Right? We're going to kind of break up how we talk about visualization based on categorical and quantitative data because the different types have different methods. Some of them are going to overlap, some of them won't. I'll point those out as we go along. All right, so we're going to begin with categorical data, and the first thing we're going to talk about is a concept known as frequency. So the frequency of some value is simply how many times it occurs in our data set. So to find the frequency of some value, we would simply take our data set and in the most rudimentary way, we would just sit there and count how many times each value shows up. Right, so below this video or somewhere in that course content page, there is a Word document or a PDF. Haven't finished it yet, so I don't know which one it's going to be. It's probably going to be a PDF, regardless. All right. One of the first things on that PDF is a data set. All right, it's titled Table 1. So this is just something I made up, and just as a silly example, this table shows the preferred nation of somebody for Avatar: The Last Airbender. So if you're not familiar with that, it's a anime. All right, there are 4 nations based on the kind of the traditional elements. Right, in this pretend data set, I asked people which one would you like to be a part of if it was a real thing. Right, so that's what that is. All right. So if we were to try to find the frequency of one of those kind of 4 elements, air, water, earth, and fire, then we would simply count how many times those show up in our data set. All right, once we have the frequency, we can find what is known as a frequency distribution. So the frequency distribution is the first actual visualization tool that we're going to have. Right? It's simply a table that's going to list all of the classes or categories, whatever possible outcomes we could have, and their frequencies. So if we were to take that data set that's in that Word document and we were to create a frequency distribution, what we would do is we would count how many of each possible outcome is in our data set, and we would simply list those in a table. So for that example, our frequency distribution might look something like this. All right, we'd start by listing our classes. We could do this really in any order. If you have, you want to put them in alphabetical or what have you, that's fine. That's what I'm going to do, but it doesn't matter too much in the distribution. All right, so our classes would be air, earth, water, and fire. Those are the possible outcomes in that data set. And then we would list their frequencies. Right? So for air, once we scan that table, we'll see that there was 1 occurrence of air. We do the same for earth. We see that we have 15 people who said earth. Fire, we had 8, and water, we had 6. All right, so that is a very rudimentary frequency distribution, but that is all there is to it. We can quickly look at a frequency distribution and see that earth is the most frequent, air is the least frequent, right? It's not super informative, but especially when we're dealing with categorical data, you can't get much more informative than that anyways, so it is still a very helpful tool. All right, but again, the whole point of this is for us to easily get, kind of what's being presented to us. We can look at this, see how everything stacks up. We'll also be using this frequency distribution to create other data visualization tools. But for now, that is our frequency distribution. We're going to move on to a related topic, which is relative frequency. So the relative frequency is probably pretty much exactly what it sounds like. It is the frequency of some class relative to the rest of the data set. Right? The way that we actually go about finding it is as follows. So we're going to take the frequency of a specific class or category, and we're going to divide it by the total number of observations in our data set. Right, so this brings us to our first actual formula of the semester. Right, the relative frequency is calculated as the frequency divided by the total number of observations in our data set. Right, so frequency, it's spelled out there. N is going to be used to define or to notate either the population or sample size, depending on which we're dealing with. But in this case, we can just keep it to number of observations. How many observations do we have? All right, the total number of values. So in that table, how many individual words are there, right? How many times collectively do all of those possible outcomes occur? All right, in this case, I think it's a 5 by 6 block, so there are 30 observations, right? So n would be 30. So when we go to calculate our relative frequencies, I'm just going to do one or two as an example, and then I'll just write the whole table up. All right, so if we were looking for the relative frequency of Earth, we'll do Earth because it's going to be the simplest one. All right, that's going to be the frequency of Earth. All right, so how many times does it appear in our data set? All right, we refer back to our frequency distribution. We'll see that it was 15. Right, and then we're going to divide that by the total number of observations, which we know is 30. All right, so our relative frequency for kind of the occurrence of Earth is 0.500. All right, so that's how we would calculate those relative frequencies. So this is what our frequency and relative frequency distribution all together would look like. One of the reasons I went ahead and put the frequency back up here is because I forgot to mention something. All right, so we know that we are going to get those frequencies by just counting up the number of times each value occurs in the data set. One quick way to check to make sure that we didn't leave anything out is we can add up the numbers in the frequency column. If they add up to the total number of observations, so in this case 30, then we can be fairly confident that we did it correctly. Right? If we get something above the total number of observations or below, that means that we did something wrong. We need to go back and check our work, because if it's over, then we double counted some things. If it's under, we missed some things. All right? So it's a simple way to double check our work. All right, we have a similar thing when it comes to the relative frequency. The sum of the numbers in the relative frequency column have to add up to 1, right? Or they should add up to 1. Based on rounding, it might not be exactly 1, but if you're taking it out to 3 decimal places, then it should be at least, if you're 1/1000th off, so if you're in this 3rd decimal place and you're off, you got 0.999 or 1.001, that's okay, but they should add up to 1. However, sometimes when we are rounding, we might round weird, or just the data we're dealing with is going to give us some stuff, so that kind of, if we round by a consistent thing, we're going to get a slightly off answer by a very small amount, right? But that is our frequency. Again, we can look at this, we can see that a higher proportion, right, or a larger amount is in the Earth class, right, with a relative frequency of 0.500 versus all of these other values. Right? Once again, a simple way to present some information. All right, so now let's look at some kind of more classical ways of visualizing data. Now, we're not going to spend too much time on these because I'm going to, I assume you're all familiar with these. We will do our due diligence, but again, we're not going to spend a ton of time on this. All right, the first, or the next thing we're going to look at are bar charts. Right, so it's kind of a basic definition for a bar chart. So it's a graph in which the length of the bars corresponds to the frequency of the category. We can also use the relative frequency for a bar chart if we so choose. And there are some other things. It's not just the frequency, but it kind of illustrates the point, right? If we're looking at frequency, if we're using frequency, the height of the bar corresponds with the frequency. If you're using some other scale, right, that might be different, but the same things still apply, right? So I don't think that this is brand new information for anybody, but we are going to talk a little bit more about it because we're going to look at some guidelines for bar charts. So these are things to keep in mind if you are making a bar chart yourself, or if you are looking at a bar chart that somebody else has created. All right, so just some things to keep in mind. All right, so guidelines for bar charts, and I will say these are guidelines. If there is a good reason to disregard one of these in a particular instance, right, that can happen. But in general, these are things we should keep in mind. All right, the first guideline is that we should use a logical order for the categories / bars. All right, so what do I mean by logical order? All right, so in some cases, our data will have a logical order, especially if we're dealing with ordinal data. All right, there's going to be a way to order that stuff that makes sense. All right, if we're dealing with nominal data, we aren't necessarily going to have that, but right, in the data itself, but there are still ways that we can categorize or order it logically, right? So we could put the bars / categories in alphabetical order, right? So that we can easily find them because we know that they're in alphabetical order, so we know where to go for each one. Right, we put them in ascending order, so starting with the smallest value and increasing to the largest, right, or to the largest bar. Or we could do descending order, where we start with the category with the highest frequency and go down. Right, but we should have a logical order. Right, one, this makes our bar charts more visually appealing, which is nice. But more importantly, it makes sure that the information can easily be garnered from that bar chart. If your bars are all in a weird order, especially if you have a lot of bars, you can get lost trying to figure out where things are, right? And so if we have a logical order, that's going to help people be able to quickly and effectively get the information that you're trying to present to them if you're the one making the chart. All right, the second is that the bar charts should start at 0. The origin of a bar chart, the bottom kind of level, that should be at 0. Right? Failure to do so can lead to misleading graphs. Right? If you cut out a huge chunk where you've got all of these values, right? You can go from having something that looks like this, where the bars don't seem like they have that much of a difference, to something like this where, and that's not a great drawing, but if you don't start at 0, you skew the perspective, right? If there's a ton of stuff all the way down to the floor, I realized as soon as I started doing that, you couldn't see where my hand was going. All right, if there's a lot more bars worth, right, of a lot more bars worth, that doesn't make sense. If this was, say, started at 100 instead of 0, right, then these differences are over-exaggerated, right? The differences between these two categories, right, the magnitude of that difference is over exaggerated, right? They might be a lot closer than they appear if you don't start the bar chart at 0. All right, so we want to avoid that. When we're making charts ourselves, so that we're not misleading people. It's also something we want to keep in mind when we are looking at charts to make sure that we are not misled ourselves. So if a bar chart doesn't start at 0, you might want to ask the person who presented it to you why. Right? If there's a good reason, sometimes there is a good reason, but a lot of times, well, not a lot of times, but there might not be one. You want to make sure there's a good reason they're not starting it at 0. If they can't give you one, that's probably a red flag. All right, third is we want to keep our bar width uniform. All right, so once again, this has a lot to do with aesthetics, or aesthetics, however you pronounce that. All right, if you've got a bunch of differing bar sizes, that's going to make your bar chart look a little chaotic. It's going to make it look cluttered, and in some extreme instances, it can kind of render it useless. If you are trying to do too much stuff, kind of a style over substance approach, you can actually end up losing the information that you're trying to provide somebody, kind of completely defeating the purpose of the chart. I'm just going to go ahead and throw up the last two because they are quite related. So the fourth one is we need to label our axes, and the fifth is we need to title our charts. So these really come down to, again, you're trying to give information to people, present information to people. If people don't know what information it is that you're trying to present, they're not going to understand the point of the chart, right? If you have a chart, if you have a bar chart with no title, no axes labeled, you don't know what the variable is that you're looking at. You don't know what it is you're measuring. Is it frequency? Is it pounds? What are the units? Are there even numbers there? We don't know. All right, so it's very important to give that information to the person who is reading the chart, right? One of the best ways to do that, contained within the chart, is labeling our axes and titling the chart. If we don't have that, our reader can miss out on a lot of information that is important for them to have. All right, so in that same PDF that I mentioned a few minutes ago, there is a small example of a bar chart made using our frequency distribution on those 4 nations from that TV show. All right, so a simple example of what we are looking for. All right, there are several other types of bar charts, and if you're wanting some more information, you can look at those in your book, but we're not going to spend too much time on them, partially because they're stuff I can't really draw. So I might include those in that PDF that I put up. All right. One other type of bar chart is what's known as a stacked bar chart. All right, what a stacked bar chart does, I guess I'll just go ahead and draw something. All right, so I'm gonna only draw one bar. Usually you'd have multiple, but essentially it's a way to get multiple things, multiple pieces of information into a single chart. So each bar would likely be focused for a single category. One of my favorite examples, and this is probably the one I'll put up there, is a stacked bar chart showing medals won at the Olympics. So I'm just going to make this really big. All right. So what this looks like, and again, that chart's also going to have other columns for each other country, right? But the bars themselves were representing the country as a whole. Here we have USA. And then the bar would consist of multiple other segments, right? So say the lower segment that I've done in purple here, right, would be the number of bronze medals. Right, then we would have another section stacked on top of that for the silver medals. And then finally, the last part would be the gold medals. Right, so we get an idea of overall medal count with the entire bar, and then we can get an idea for which type of medal, bronze, silver, or gold, right, by looking at the kind of composition of our bars. Right, so these are fairly useful in comparison. They are meant to kind of give us a general idea of really the biggest thing, the most obvious thing when looking at one of these would be differences in total medal count. And we can get a general idea of differences in types of medals, although they can get a little hard to see. All right, it's not an exact, and this is not an exact thing. All right, I'll put that one on that PDF so that you guys can see what I'm talking about there. But that is a stacked bar chart. There are other variations of the stacked bar chart, but that is essentially what that is. Right, the last, or the second, I guess the third type of bar chart we're going to talk about, and I am not going to draw this one because I literally can't. These are known as 3D bar charts. All right, I'll put an example of this up on that PDF as well. You might have used one. Essentially, in the simplest form, it is a regular bar chart that just has a 3D effect on it, so that you have kind of the three-dimensional bars. Something that you can do in Excel or PowerPoint. We're probably more likely to do it in Excel. When you are making a bar chart, more extreme examples will add more axes. I'll be honest, I hate these types of charts. I'm not really sure what they're useful for. I'll put one, and I'll go ahead and tell you that the one I'm putting up on that PDF is kind of a biased one, because it's a particularly bad looking one in my opinion. They're just very difficult to read, especially when you're trying to present something 3D in 2 dimensions, right, printed out on a piece of paper. Usually doesn't go well. All right, they're not easy to read. Again, defeating the purpose of having a chart, of having some method of visualizing data, right? If you're trying to get me to understand what's going on and I can't interpret the graph, that's a bad graph. All right, so those are those 3D bar charts. All right, next we will briefly talk about pie charts. Alright, so a pie chart, as probably most, if not all of us, are already aware, it's a circular chart where it's divided up for the proportion of observations for each category. So we've got slices that correspond with those proportions. All right, pretty common. One thing with these, again, we can do this with, you'll often see them portrayed as percentages or in relative frequency, so that each slice representing those relative frequencies or a percentage, but we can also do those with frequencies. All right, there is an example, much like that, the first bar chart example, there is an example of these pie charts in that PDF. Again, very basic, and that's based off of the relative frequency distribution for our Avatar: The Last Airbender example. All right. Really, the only thing I'll say about these, they're pretty simple. One thing, if you're making a pie chart, you gotta make sure that it adds up to what it's supposed to, right? So if you're doing a relative frequency or a percentage-based pie chart, you gotta make sure that those relative frequencies equal 1 or the percentages equal 100%. All right, if you don't do it, then it's then it doesn't make any sense, right? There's a pretty famous example of, or well, I don't know how famous it is, but it's circulated around. I think it was a political poll. It was a news station kind of looking at who people were going to vote for in a political primary, I believe, right? And they structured the question obviously in a way that was not suitable for that data to then be used for a pie chart, but they did anyways. They tried to use it, and so the percentages did not add up to 100, and in fact added up to well over 100. So we want to make, just in general, make sure your data is appropriate for what you're trying to do with it, especially when we're talking about these methods of visualization. All right, you want to make sure that what you're working with is suitable for your methods. All right, so we will go ahead and end our video there. In the next one, we will pick up by looking at ways of visualizing data for quantitative data.